Good afternoon, you're all very welcome. My name is Noel Carr from NVM Limited. I've to give you a presentation on contactless instrumentation, all from the OTT range. And just before I do that, I'll give you a quick rundown on NVM and what we're about. We're an environmental monitoring company. We've been operating since 2004. And during that time we've been lucky enough to work with a number of public and private agencies and organizations, and we believe we've gathered together some practical knowledge on instrumentation, installations and setups and telemetry solutions, and hopefully it puts us in a good position to be able to give this presentation to you today. So what we'd like to do today is to provide a brief overview of contactless instrumentation that's available. In particular, we're going to talk about the SVR100 and provide a system approach and some non-contact measurement principles and some key advantages of using this equipment. Do something similar for the RLS unit, and then show some software solutions to include the Protus 2, and then some COM solutions with regards to SDI 4020 milliamp and RS485. And hopefully then, if we've got enough time, we'll talk about some solutions and how it works, and maybe get some technical data in there also. Get things moving, the SVR100 is a surface velocity radar device used for measuring channel flow in open channels and large watercourses. The RLS is a radar level sensor. It's a non-contact water level sensor, and that's used also on water surface and for collecting water data. So the SVR100. The SVR100 is a simple non-contact compact surface water velocity radar sensor. These units are designed for measuring flow in open channels and rivers where reliable velocity data is required continuously during floods or periods of high concentration of suspended sediments. As you can see from the image, the unit's quite a small compact unit, and it can fit neatly on any bridge deck or bridge structure. So some general applications. As you can see, the units are capable of being mounted on arms reaching off from the edge of bridge structures, or we can place them right on the bridge structure, and it can be used quite neatly and tidily from there. These units are available to be used on rivers, on streams, on canals and man-made canals, and you can see again from some of the photos there that there's lots of different applications where they can be used from. So a system approach. These units come with a SDI12 comms or Modbus protocol capabilities. They're usually used to and designed to interact with a variety of data loggers. So the loggers that we provide through the OTT instrumentation range are the OTT-NetDL, the Sutron SatLink 3, or the X-Link. Now predominantly in Ireland, the OTT-NetDL is used by the EPA, the OPW, the Marine Institute, Waterways Ireland, and on lots of private jobs also. The reason for this is it's got great capabilities, and you can see from the bottom of the slide here there's lots of advantages for using these equipment. Some of the applications here are split between the Sutron SatLink and the X-Link, but like I said, the OTT-NetDL is the product that lots of our customers use. And you can see in the image here to your right that this is a typical setup, so it shows the OTT-NetDL logger in the base station here. Okay, so what we've got here now is some general information on measurement principles. So the SVR100 is positioned on a bridge deck or bridge structure. It's used for collecting measurement velocities either continuously or during flood events or during periods of high concentrations of suspended sediments. The sensor is usually mounted, like I said, on a bridge deck or on a bridge structure. It's usually tried to be placed away from any possibilities of floating debris, and it's mounted using the flexible brackets that allow the unit to be moved or changed to either a vertical or a horizontal installation. So showing here now is non-contact measurement principles just of how the units will work. So the SVR100 uses the Doppler effect to collect surface water velocities and measure them. What we normally do is we normally set the device up using the standard set of applications. Usually a 30-degree angle is used to face the unit to the water surface, and therefore allowing the transmission of the electromagnetic waves from the surface water to the unit in order to collect surface water velocities. This then can be sent to the hydro station, which allows it then to come back to the data set where the user can review the data shown. And now for the science bit. So discharge computation can be calculated on any open water course using the following equation, with Q being discharge and A the area of the cross section normal to the flow direction. How the SVR100 assists is it measures velocity of the water at surface area, and then using the Protus 2 software we can calculate the K values and K factors on either a theoretical model or by applying the velocity index method. How we do this is it's shown here in these diagrams, that you can see where the surface velocity is measured by the SVR100, and then from there we use our calculation method and then, like I said, apply the details within the Protus 2 software to allow us to gain our K values, which then can allow us to calculate our discharge. So just to run through some key advantages of the SVR100. Like I said previously, it is quite a compact sensor. It can fit on many applications in relation to bridge or bridge structures. It's quite an easy setup. It allows for low power consumption, so it's an ideal unit to use on a solar station, which avoids the requirement for mains power. And as we can see from the photos here, it all can sit quite tidy at any station area. Additional advantages of the SVR100 are the application of filters. These are commands that can be sent through the software to the SVR100 that filter influences from the environment, such as wind, waves, vibration or precipitation, which can all add to erroneous data. By applying these filters, it allows us to collect accurate data at all times where possible. So once installed, the SVR100 provides some additional features. One is a vibration sensor, which allows the user to be notified and informed if the measurements are poor due to influence of vibration from external factors. So if we have a sensor that's installed on a road bridge over water, what sometimes might happen is that heavy loads or heavy traffic may cause some unwarranted vibration, which the sensor would pick up then and allow the user to know if the data is of good quality or not. Again, a tilt sensor is also used in this, and again that's important to know that if something has changed in the measurement setup on site, and by allowing the data to be managed and to be available through the SDI12 comms, we can have a look at the inclination values in degrees and determine if they have slipped or changed in any way. So again, these are additional features to the unit and quite beneficial to ensure that the data is collected correctly. Just to recap on everything in relation to the SVR100, because of its small size and its general application, as you can see from the photo here, it only takes a couple of screws to put the unit up and set in place. It minimizes time on site. It's a pretty simple system integration, so the applications are made to be quite user-friendly. Realistically, there's not a whole lot of training or knowledge needed to set up the sensor, and again, using the SDI12 protocol, we can send filters or we can manage any issues on site remotely. Metadata, these functions can be applied to know if measurements are good or if they're bad, and virtually the unit is maintenance free once installed. It's got an IP rating of 68, and if there is some cleaning that is required, it really is only just to clean the Teflon panel at the front of the unit, and that realistically only needs to be applied once, maybe twice a year, depending on the environment. So just to give some information on software solutions, we've already spoke about the Protus 2 software, which is a discharge management software for managing and generating calibration data and reports. And like I've previously noted, it is quite an easy to use setup system. As you can see, the image there to your right, which shows a snapshot from the software setups. All the information is there in front of you along with graphical representations, so it allows you to review the data quite easily. All of the software is supplied with step-by-step user guides, and NVM are available and will assist in any way in a support element, and all the information does come through clear and comprehensively, so that should make it quite easy to use. Just again to point out how those filters work, so what we can see is the filters are applied to rule out any spikes or noise in the data that's introduced from any external environmental factors. Again, we can apply these filters to the software through our SDI12 commands. We can identify influences by looking at the measurement and applying the filters again on vibration and sensors in relation to tilt, like I've previously mentioned. And then we can also set up automatic detection of flow directions. So during slow velocities, wind may create waves or change the direction of a flow upstream, so therefore these filters can be applied to show if measurements or the flow is going in the wrong direction. So again, these are all add-ons to allow the data to be produced in a user-friendly way and to give confidence in the instrument and the instrument data. So to go on to the second instrument in our presentation, it's the RLS, or radar level sensor. This unit is again designed for surface water level applications. The RLS, or radar level sensor, it works quite similar to the SVR100 in that it's a quite easy unit to install. It's got very little maintenance. It uses a 420 milliamp or SDI 12 comms setup, and because of its compact size, it can be used practically on applications either locally or on remote setups, which is shown in the images here on the slide. Again, because this is a low power unit and it's got low power consumption, it's quite practical to use this with a solar setup, which is always beneficial. So how does it work? The device uses a pulse radar technology that transmits pulses. So these pulses in 24 gigahertz band are directed towards the surface of the water, and as they return, the time the pulses take from transmission to reception are used to calculate the distance between the sensor and the water surface. Just some basic measurement technology then. So the device really measures the distance between the sensor and the water surface. We refer to this distance to water as X, and then the actual water level or stage floor area is referred to as Y, and then this is automatically calculated by the RLS device using input measurements which we use during setup and placement of the device. As you can see in the image here, this device is under a bridge deck, and that's measuring the distance to water in X, and then from water going back up then to Y, and that allows for the calculation to be made. So site selection. How this device is set up, it really depends on what areas we have. Ideally, it can be shown in the photos here that it can go underneath a bridge or on the edge of a bridge structure or bridge deck, but we must be careful on our selections of sensor mountings so that we reduce any negative influence because of changes in temperature on bridge structures, especially if they're steel structures. And we need to make sure that when we're mounting this unit that it's not going to be influenced by too many external factors. So we've got here some typical setups of bridge installations at ESB stations in Inishcarra in Cork and in Ballyshannon in Donegal. As you can see, the devices are mounted on arms that reach out over the water. Both of these systems allow for the unit to be retracted back into the main column, and then there is a pivot on the unit which allows us to turn the unit into the bridge deck or structure that we're working on, which allows us to review or service the unit quite practically and safely without having to go out over the water's edge. Again, here's another image of the Eastlink bridge, and the RLS device is shown here, and I think this image shows you how practical and easy it is to actually install the unit using the bracket that comes with the unit. So again, this unit can be drawn back in onto dry land where we can service it and check it quite easily without any great effort. Some benefits of using the RLS, and again these can be applied to the SVR100, and there's a decrease in on-site maintenance and data post-processing. because the software we're using and the measurement strategies we can apply to maximize the data availability and decrease some site visit. Because of the reduced power consumption and the low power requirements, if it's used on a solar panel system, it's generating its own power, which is very beneficial. Like we've already mentioned, there's little or no maintenance in these. They may require some checks occasionally, but that's just to make sure that the unit continues running as it should do. With the filters and setups and applications we can use through our comms, we can eliminate some influences from temperature and atmospheric pressure, and also like we said previously with the SVO100, we can eliminate external vibration or tilt or environmental influences. These units are reliable, they work. So the long-term robust non-contact element of the device means that you've got a device that will stay out in all kinds of environment and has a long product life. With easy to use on-site integration and installation, this all saves time, and because of the multiple communication interfaces, it's quite an easy system to use and operate. So just to show you some solutions and how the unit would work, we've got both units here from our presentation showing you that they use their SDI12 or 420 milliamp or the RS485 setups. They then get sent through to the logger. From the logger then, either through USB or through remote comms, it goes out to the user and they're able to review their data then using their interfaces and software. Just another method on how that's done again. So using the SVO100, we show that that's is able to communicate to a USB or an SDI interface. We've got the external power supply there showing that, you know, we can use many different methods to gain power to device. Ideally, if we use solar, it's using its own power and generating its own power. And again, then that goes back to the user through a USB or an external protocol, be it FTP or remote comms. And again, then the user can retrieve his measurement data either continuously or as single measurements, or populate graph or tables to allow them to plan or review measurement data over time. So some brief technical data, and these are all available on our website. We can provide the technical data on all instruments that we put out on site. So again, this is just some general technical information on the SVR 100, and it's quite similar then for the RLS device that we've shown earlier on today. So just nearing the end of our presentation, just a brief summary to explain that both solutions that we've explained today for contactless instrumentation are applicable to many different project setups. Given the small footprint for each device, they give themselves to practical installations, and I think we showed you that in some images throughout our presentation. To an extent, these devices are maintenance free. Once in place, they generally work as they should. and given that they have low power consumption, they can be used with solar applications, which makes them much more practical in use in the outdoor environment. Both units have got long-term reliability and can do so in many different environments, and given the Irish weather, I think anything that works well in Ireland, it generally works well anywhere else, so that's a positive. And again, our software, as shown, is quite user friendly and easy to use. So that's it basically from myself. Thank you very much for your time and interest, and I hope you enjoy the rest of the presentations. Thank you.